Good afternoon, everybody. Welcome to the webinar series on community building effectiveness. I'll just wait for a couple of minutes to see if we'll have any other participants joining. I'm admitting them as they join. So probably 1 or 2 minutes we'll wait and then get started. Again, for all the participants, I just would like to inform you that we are recording this session so that we have this for participants who cannot be present, and also for anybody who wants to go back and revisit the video. So I hope I have your permission to do the recording. Good afternoon, everybody. Thanks for attending the webinar series on evaluating community building effectiveness of transportation investment. We have about 10, 11 or 12 participants, so I think it's a good place to start. What I'll do is I'll let all of you introduce yourselves quickly, just so that we know who is in the meeting, and then we'll get to a presentation. I'll start with my introduction. My name is Naveen Eluru. I'm a faculty at University of Central Florida. We've been working here now for the last 6 years. We do a lot of work with the DOT in the area of planning, mainly developing new methods and also developing tools that are practical and useful for DOT planning. We also work in passenger travel and freight travel. I have with me one of my PhD students, Sudipta Dey. He'll be also partly presenting a part of this seminar. Sudipta, can you introduce yourself?
Yes, Dr. Naveen. I am Sudipta Dey Tirtha. I'm a PhD student at UCF and currently working under the supervision of Dr. Naveen. I started my PhD in fall 2018, and I completed my master's this semester and continuing my PhD.
Okay, so if you can follow the order of the participants in the Zoom list, it will be efficient. So can we start with you, Chris, if you can?
Yes, it's Chris Leffert from FDOT District 7.
Okay, thank you. I thought we lost Colleen.
This is Colleen. Sorry, I don't have the same order you do. This is Colleen Nicklin with the River to Sea TPO.
Okay, thank you. Brenda. Brenda, you want to introduce yourself quickly?
And I think she may have stepped away.
Yeah. Okay. Jason.
Oh, sorry. I couldn't figure out the mute. This is Brenda Young with FDOT District 5 Modal Development. My apologies.
Okay, thanks, Brenda. Jason?
Hi, this is Jason Learned with District 5 Planning and Environmental Management.
Ken?
Hi, Ken Spitz, Transportation Planning Manager, DOT District 7.
Okay, thank you. Nick, I think, is next.
Nick Lepp, Metroplan Orlando, Director of Transportation Planning.
Hi, this is Ryan Cunningham with Kittleson, FDOT consultant, working with Jeremy Dillmore and helping Dr. Eluru with the oversight on this project.
Thank you, Ryan. Samuel?
Hi, this is Samiul Hasan. I'm an assistant professor at UCF as a co-PI of this project.
Is that you, Tushar?
Hey, this is Tushar Patel, District 5, TSM&O.
Okay, thank you. Jay Chow, you just joined. Can you introduce yourself?
Sorry?
Just introduce yourselves. Thank you.
Okay, so I'm a second year PhD student, and my supervisor is Dr. Samuel Hasan.
Yeah, okay. I think Suraj, if you can, I don't see a microphone for you, but if you can introduce yourself, that's fine. Okay. Yes, I think he's having some technical challenge. We'll stop there. Again, it's great to see participation from different parts of different districts in DOT. Also, we are very happy to have Metroplan represented by Nick. So I'm looking forward to interacting with you all. So what we have is 3 seminars that we'll be doing that cover the 3 years project that we did with DOT in 3 different phases. In the first phase, or in the first webinar, what we are focusing on is how we generated data for measures of effectiveness for community buildings. We'll discuss some of the measures we developed, how we collected the data, how we generated the results, and then we'll present a brief analysis of that. In the second webinar, we will show how social media data analytics can be utilized to understand how people perceive the various transportation investments. Do we get any feedback from the public? What can we understand from Twitter data, and what are the approaches that can be used to gather the data is something we'll present in webinar 2. In webinar 3, what we'll focus on is we have different sets of measures of effectiveness, and as all of you know, there are many trade-offs that have to be made between these different measures of effectiveness. We cannot do well on all measures of effectiveness simultaneously. There is some give and take here and there. So in that context, how do we do multi-criterion decision-making process? How do we provide a tool that the DOT can apply and use a framework that can be readily used by DOT for their project analysis? So these are the 3 different webinars that we have. In this webinar, we'll focus on the measures of effectiveness that we selected and the data analysis that we did for those measures of effectiveness that we selected. I'm hoping everybody can see my slides. Just one second. So this is the brief outline of the webinar today. I'll give you a brief introduction of the proposed project and then discuss the objectives. We'll present the different measures of effectiveness we have identified, and then the data analysis and preparation steps for the MOEs. Some of it is very data intensive. We did a lot of work for different years using GIS. Sudipta will be presenting part of that. Obviously, we'll not be able to cover data analysis of all of the measures of effectiveness. So we'll provide an illustration today, and we'll also provide a supplemental video for another measures of effectiveness so that people who are interested in reproducing this work or applying this work in a different context have a very easy to use tutorial and a hands-on guide to do that. Then we'll conclude the presentation and some acknowledgements. Again, I want this webinar to be interactive, so feel free to stop me at any point if you have any question. I'll do my best to answer those questions. So in terms of the research background, the reason we started looking at community effectiveness of transportation infrastructure is because we all know that transport infrastructure is primarily designed to enhance movement of people and goods. But as you all know, the impact does not stop there. We are influencing the communities and neighborhoods through which these transportation facilities pass through. There is an impact on land use, residential decisions are affected, residential location decisions are affected, activity decisions are affected. Where are people going to participate in activities? What travel patterns are they going to use? Are they driving, walking? How much of physical activity are they doing? All of these, and finally, the overall quality of life is influenced by transportation infrastructure measures. So in terms of these infrastructure projects, in addition to providing the direct transportation impacts, they're building connections across regions. They also are shaping, guiding, and strengthening our community life. And one more facet that is of particular relevance is the emergence of connected vehicles, infrastructure associated with that, driverless cars, electric cars, and mobility as a service. All of these new technologies that are coming into transportation actually will have a significant role to play if we want to build a true smart city. As we all know, especially all of you working in the field know, a true smart city is only as smart as the technology is only one component of it. It is only as smart as the software designed to use this technology. So any effort to build a true smart city will need to focus on transportation and integrating transportation with the community, users, planners, and everybody involved in the transportation field. So with that sense, it is important to consider transportation as not purely a travel time reduction measure or mode choice, but you also want to focus on what are the impacts on overall community and beyond. So with that said, the main objectives of the proposed project are to understand the role of transportation in community building. Towards this end, we wanted to look at what data is available. Again, we wanted to bring about a quantitative analysis of these community building measures. So we wanted to see what are the measures of effectiveness that can be actually be analyzed with readily available, publicly accessible data. Again, we cannot look at buying new data all the time. That on a long time horizon, that's a very costly process. So what we're looking at here is we're trying to find publicly accessible data sources that we can use to generate measures of effectiveness for community building. That was one of the first objectives of the project. The second objective of the project is looking at using social media data. So can we develop custom queries so that we can download data on how people are responding to the DOT announcements, how people are responding to the announcements for new projects, or how people are liking the new investment related project. So if there is a new, as I-4 construction is happening, we can actually perceive positive or negative feedback on the construction, the new facilities that are ready, and how that is changing how people interact with transportation. So we'll provide and his group has led that work, where we are looking at how we can draw insights from social media, use those insights for enhancing the connectivity between transportation agencies and the community. Finally, the third objective is, okay, we are developing all of these measures of effectiveness, and we know that some of these trade off with each other. So for a particular project, not all measures of effectiveness go up simultaneously. Wanted to look at assessment of these projects so that we can come up with a multi-criteria decision-making process that will allow us to identify and rank the different projects. So that's another part of the project that we wanted to focus on. So we chose 3 projects for evaluation in the District 5 region. One was obviously the major project in terms of, there are 2 major projects that happened recently. So the SunRail commuter rail extension is one, and also the I-4 expansion are the 2 projects, one public transit and one roadway expansion. Added Juice bike share as a project. Unfortunately, now Juice has been disbanded, but we still, by the time we finished, the city decided to move in another direction and bike share. But we have these 3 projects, and we evaluated different measures for these 3 projects. So in terms of the evaluation process, I'll briefly describe what we did for the 3 projects, and then we'll get into the measures of effectiveness. So for the SunRail, we focused on 3 categories of stations, phase 1 and phase 2 stations, and we further divided the phase 1 stations as outside downtown and core downtown. Again, all of you from Orlando would know these. So we have 9 stations in the downtown region, outside downtown region, and 3 stations in Link Central, Church Street, and Orlando Amtrak station in the core downtown region. And phase 2 stations were also considered in another one. The second part of the second project that we looked at is I-4 expansion. We divided the I-4 stretches, each about 5 to 5.5 miles, with the 4 attractions, downtown area, Ivanhoe, and Altamonte area. For bike share stations, it was a little tricky in the sense that the Juice system covers substantially smaller ground compared to the other 2 projects. We have a lot of mileage in the I-4 and a SunRail project that is covered, but the bike share stations, the system is predominantly in downtown Orlando. So we looked at the core area, stations within that area, and stations outside of that downtown area. So this is how we divided the stations for the Juice project. So I want to start discussing the data preparation, but before I do that, I want to discuss the different of effectiveness. Again, the criterion for the measures of effectiveness was based on data availability. We did a comprehensive review and looked at what measures were used in understanding some form of community building in transportation in the past. We found some literature, and we have a detailed report that we summarized that we'll provide as an addendum to the material that we're providing here. In the interest of time, I'm not to a summary of the literature review. Here, we found some useful insights from there, and then we looked at the different measures for which data can be accessed easily, or at least something is available, and we selected these 5 measures. The first measure is property value change. I think as transportation infrastructure comes into a new region, the community or the residents who are living there would be happier if their property value is appreciated. So property value change is important from that perspective, and also increasing property value brings revenue for different local agencies. So there are 2 reasons why we are focusing on this. So that could increase the ability of these agencies to fund different transportation initiatives, or different mechanisms to improve community building and improve cohesiveness among the community. The second measure that we looked at is changes to job accessibility. So here we drew our data from the Census Bureau. Just to go back, for property value, we were able to get a very detailed parcel level data layers from Florida Department of Revenue. So we used those to compute how the property value have changed years. The third measure that we looked at is commuting time change. So we wanted to see what is the impact of the transport project on commute times for people around that region. The fourth measure that we looked at is land use type change. So what we did was, using disaggregate parcel level data, we monitored what happened to the different parcels with time. So how many of these parcels that were vacant were converted to residential? How many of those parcels that were vacant were converted to industrial or office space, or how many did not change? So we wanted to understand what is the impact of the project in the vicinity of the project in terms of land use change in the region. Then finally, we also wanted to focus on how the vulnerable road users are changing, or their are changing. So we how travel patterns for zero car households were altered. Again, even for this, we use data from the Census Bureau and American Community Survey, and we measured that. So what I'll do is I'll start with the first measure of effectiveness, which is the property value that we used. And some of the GIS data analysis is involved. So as I explain this measure, we'll show what we're trying to do, and then Sudipta will present the step-by-step process for people who are interested in that. So we'll do it that way. So what we did was, we used the Florida Department of Revenue's layer, and we wanted to focus on every parcel in the region. So we are focusing on every individual single family house, every multi-family house. So we are looking at how property values of this change over there. So the good thing is this data is available. Again, it is a lot of data processing, because you're looking at a parcel by parcel records, and it takes time to process this data, but I think it provides immense value in understanding comprehensively how prices are changing. The Department of Revenue provides a wide variety of land use categories. What we did was, we needed to group them into different combinations. After grouping them, we focused on 5 of those categories. We grouped them into 12 categories. Some of them are purely vacant, water, recreational facilities, public facilities, and so on. Obviously, we did not focus on those facilities. We looked at single family residential, multifamily residential, retail and office, industrial, and institutional facilities. Again, the selection was purely based on measures of how many measures we can generate and compute. We could do other measures if needed. And for determining the price or the property value, we used the just value reported. To be sure, these are not sales. We are not just looking at properties that were sold and purchased. So we will not know the real sale price, but what we know is a uniform assessed price based on the property appraiser's value. So the property every year is appraised for tax purposes. That's what is being considered effectively as the value that we use in our assessment. So we identified the various stations that we have in SunRail. So we are explaining this for the SunRail project now. What we did was, we drew buffers around each SunRail station. We drew a 1 mile buffer, and we looked at parcels within each of these buffers. So if you look at the beginning in the original regions, the buffers are quite well spaced. Even in the Altamonte region, they are reasonably well spaced with little overlap. So it was there were no issues. But if you look at the downtown core area, obviously the buffers overlap because the stations are much closer than the 1 mile. So in that case, we had to be careful. So we selectively, we allocated parcels one SunRail station. So we don't want to double count. So we allocated the parcel to the closest SunRail station based on the distance. So that we are not accounting for the impact of that station in multiple parcels. And then once we did this, we had all of these buffers. So when we are modeling property value, as all of you know, Orlando has been experiencing a good gain in property values all around the region. So we cannot simply attribute the increase in property value in that buffer area to the SunRail station, because as a region, we have a base level of increase that is happening because the economy was doing well. Again, I don't know how the COVID-19 is going to impact the region. Obviously, tourism is substantially affected, so we might have downside in a few months. But what we the years we model were from 2011 to 2016, and clearly there was a substantial increase in real estate values all over the region. So we need to account for that base increase around in the region. So what we did was we identified the case area and a control area to account for that. So what I'm showing you here is the case area, which means these are the stations that are directly affected by the transportation infrastructure project. In this case, the SunRail station. Now, control area in statistical terms refers to properties that are of similar type and similar price, but are not affected by the treatment. So these are the case area stations, are stations that are affected by the treatment. In this case, the treatment is the commuter rail. The control areas are similar properties or similar parcels, but they are far off away from the SunRail station, that they are not affected by that SunRail station. Again, as you all know, in transportation, the effect of a transportation infrastructure has a large spatial effect, and it is challenging, but at the same time we are trying to come up with at least some form of control. So what we did for control is we expanded the buffer around each station. So we said 1 mile is the area of influence of the SunRail station. So we'll take everything from 2 miles. So we drew a buffer of 2 miles, starting at the 2 mile circumference, going up to 8 miles. So this is what I'm trying to show here. So this is the interior circle of 2 miles. This is the exterior circle of 6 miles. So we're saying parcels in this area, taking out the central area, the area in this ring, if you will, of area are stations that are less likely to be affected by the SunRail station. So these parcels should serve as control. So we will monitor increase in prices within the first 1 mile, and also increase of prices within this control area. That way, we will be able to offset and say, okay, if the control area increased by 10% and the case area increased by 12%, we can say 2% of the increase can potentially be attributed to SunRail. Again, there will always be other factors that will be there. We have to be careful in making these conclusions, but having a control at least gives us qualitatively a benchmark to measure. So for example, if we don't have a benchmark, we might overestimate and say, oh, SunRail is creating 70%, 100% increases in property values, when in reality, maybe 70% is just the region growing and creating that effect. So we believe, again, in literature also we saw similar approaches. This provides a more realistic assessment of the impact of the project. Again, we did the same idea for I-4 expansion also. We'll explain that. And in selecting the parcels, obviously we cannot find identical parcels. So what we did is we selected parcels of the same land use type and property values within the same ballpark. Again, we said an error of 10 to 15% was the mean property value that we used. We said we are looking for areas, parcels which are within that price range, so that we know that we are looking at a 300,000 parcel in the control area, in the case area, and a 300,000 or a 310,000 parcel in the control area. That way, when we compare the changes in the price with time, comparing similar properties, and a more fair comparison exists in that way. So once we did that, we computed property values per land use category, and then we used that to see the trends in how property values are changing. Okay, so with this big picture approach of how we are doing this, what I will do is now I'll let Sudipta show how we actually went ahead and did these individual steps. So how did we identify these parcels? How did we get to selecting these records? How did we compute the values? And then I'll continue with the analysis of the different other measures and also the results from our analysis. Sudipta, can you start sharing? I'll stop sharing for now. Yeah.
Okay. Hello, everyone. I am Sudipta Dey Tirtha, a PhD student at UCF. Now I will present the data preparation steps for different MOEs, especially for the property value chains in our project. So here is our measure of effectiveness. We considered 5 MOEs in our study, and Dr. Naveen discussed about them in details in his part. And MOE computation process is performed using ArcGIS and SPSS for the time period from 2011 to 2017. And for the sake of brevity, we present the layer preparation steps for 2012 and for the SunRail stations only. And in case of property value change, we considered county parcel shapefiles. We downloaded the shapefiles from the Department of Revenue website. And the county parcel shapefile contains unique parcels within each county. And in our study, we considered 4 counties where SunRail stations are located. And if you see the figure, you will see that there are 4 county layers. And if you open the attribute table of the county layers, you will find unique parcel IDs, which are actually unique for the parcels. And this will be very valuable information in our analysis. And now we have to project the coordinate systems of 4 county layers into a common single coordinate system. And to perform this, we need to follow several steps in ArcGIS. At first, we have to go the Art toolbox and go to data management tools. And then we need to find projection and transformation and select project. And then you have to provide the input dataset in the feature class. And here we have to provide the county layers. And then we have to select the output coordinate system. Then you'll find 3 types of coordinate system. Here we used projected coordinate system. And then you have to navigate to NAD 1983 UTM zone 17N. We use these coordinate systems for all of the county layers. And you have to do the task for all of the county layers. And then you have to prepare the parcel data layer. In our county layer, we have the information about parcel ID, but we don't have the information about the land use and the property value. So for that, we used null files. We downloaded the null file from the Department of Revenue website. And if you open the null file in SPSS, you will find parcel ID column. This will be helpful. And then you will also have the information about the land uses, which are numerically coded. And you will have the just value. We considered the just value as a surrogate measure of the property value. And Dr. Naveen talked about why we took just value as a surrogate measure. And then you have to merge this information in the county layer file. So in ArcGIS, you have to select the county layer, then you have to go join and relate, and then go to join option. And then you have to provide the unique identification number from the county layer. Then you have to select the null file you want to merge, and then you have to provide the identification number from the null file. And then you will be able to merge the information from the null file into the county layer file. And then you will find the just value in your layer file and the land use type. And from this information, you may need to create another column of land use, which will be text in type. And you may need to also calculate the parcel area. And that should be in an appropriate unit. To do that, you have to follow some steps in ArcGIS. First of all, you have to go to the drop-down bar and then select add field because you are trying to add a new column. And then you have to select the data type. It should be text for the land use. And then you have to know the corresponding land use code for the land use category we are interested in. We considered 5 land use categories, and we also know the land use code for them. So you have to calculate the field of the new column you created. And then we used VB script to record the new column. And then you need to calculate the area of the each parcel. To create a new column, you have to select the data type as double because this will be a numeric column. Then you have to calculate the geometry for that column. And then you provide the property of the data as area, and the unit should be acres for our study. And after that, you'll be able to get the land area and the property value and the land use type for the parcels. After that, you have to merge the 4 counties into a single county layer. To do that, you have to use merge option in ArcGIS. So you have to go geoprocessing, then you have to go merge. Then in the input data set, you have to provide all of the 4 counties and merge them together. After that, we prepared the layer for case area and the control area. For that, we used all of the 17 SunRail stations, and we have the stations in 3 segments: downtown stations, outside downtown stations, and phase 2 stations. First of all, we created the buffer area for case area selection. We created 1 mile buffer around all of the stations, and to do that, you have to go geoprocessing, then buffer. Then you have to select all of the 17 stations. Then you have to provide the radius of the buffer. For case area, we will be using 1 mile buffer, and the unit will be miles, and then you have to create the buffer. So we have 17 buffers here. And now we have to clip all the buffers with the merged counties. To clip the buffer with the merged counties, you have to use the clip option from the geoprocessing tools. So you have to go geoprocessing, then you have to go clip, then you have to provide the input feature. Here, the input feature will be the merged counties. And then you have to provide the clip feature. Clip feature will be the 17 buffers we created. Then the buffers will be clipped with the merged counties, but you may face some issues with the overlapping buffers. Then we solve the problem using proximity analysis. Dr. Naveen said we assign the parcel to the nearest station. So to do that, we need near generate table operation. Using this tool, we actually calculated the nearest distance between the parcel and the nearest station and assign the parcel to the nearest station. And to do that, you have to go geoprocessing, then our toolbox, and find the near generate table. You also find near generate table using the catalog option. And then you have to provide the input feature as the clip buffer, and the near feature will be the SunRail stations. And then you have to press OK, and near generate table will be created. Using near generate table, you will be able to create 3 new fields. The first field is the in FID, which are unique to the parcel ID. Then near FID indicates the SunRail stations, and near distance indicate the distance between parcel and the nearest station. So after you created this table, you need to export this table as DBF file, and the future analysis you can perform using that DBF file. So after creating the DBF file, you have to open the file in SPSS and perform the analysis. When you open the DBA file, you'll find few informations like the first column is the parcel ID. This column indicates the area. Here is our SunRail stations. This is the just value. And then this is our land use types. And if you now want to calculate the average property value per land use types, you have to go to data, then go to aggregate option. Then you have to provide land use as the break variable. And in summary variable, you have to provide the just value and the area. And now, if you create a new file, you will find the sum of the property value and sum of the area by land use types. And using this information, you'll be able to calculate the average property value by land use type. But in our study, we are also interested to identify the average property value by land use type and also for the SunRail station. So in that case, you have to provide the near FID in the break variable, and then you'll be able to find the average property value for different SunRail stations and for land use type. And here is our final output. In this table, we can see the SunRail stations. We have 17 stations in total, but in here we showed 3 stations, and this is our land use types. And for each station and land use type, we will find the average property value. And this is for the case. And now we have to do the same task for the control. The only difference in control that we have to create a 2-mile buffer and 8-mile buffer, and then we have to erase the 2-mile buffer from the 8-mile buffer to have our control area. And then based on the land use type and the property value range, the control areas for the analysis will be identified. Finally, we will select same number of control parcels for each of the land use type. And finally, control parcels will be assigned to the nearest stations by using nearest distance analysis. So how can we create the control area? First of all, we have to create a 8-mile buffer and a 2-mile buffer around the SunRail stations. Then we have to erase the 2-mile buffer from the 8-mile buffer. To erase the buffer, we have to go our toolbox and go to the option erase. And then we have to provide the input feature as the 8-mile buffer, that is the larger buffer. And then in the erase, we have to provide 2-mile buffer. And then you'll be able to create the desired control area for the analysis. And in the next steps, we have to follow the same procedure for case area. And this is the way we actually process our property value change. And this is all from my end. So the remaining part of the presentation will be continued by Dr. Naveen. Thank you, everyone.
Naveen, I think you're still on mute.
Yes, thank you, Ryan. Yeah, so the idea of what Sudipta presented was to show how to do this exercise. Again, we're only presenting it for one task. Obviously, as you all know, it is a very lengthy process in doing that. But we wanted to give you a flavor of what goes into generating this information. Now what I'll do is I'll quickly describe how we did it for different measures of effectiveness and then present some results. So for I4 is we used a similar idea for I4, but it's slightly different in the sense that you don't have stations, you have a continuous facility. So our control area was a 1-mile buffer around the I4 site. So you can see that it goes 1 mile in all directions in that sense. And then we used the control area same as the SunRail, but obviously it won't be circular, but we're trying to say we'll go 2 miles on both sides. That area we won't touch. It will be 2 to 6 miles from I-4 along that direction. So that's what the idea we used. And then once you select your control area and case area, the process that we used is similar. We used the same approach of compiling data on parcels within the control area and within the case area using the same process. And we did it separately for the 4 phases, the 4 attractions, so that we can see if the trends are different across these different phases. That's what we did. For juice, we had stations for bike share stations. The juice project was a little more challenging in the sense that because it was such a small area, the selecting the control and case area was very difficult. So what we did was we simply focused on how the property values changed for downtown stations and outside the downtown stations. That way, the control and case were looked at it differently in this context, because it wasn't easy to come up with control and case in this region. And here we used only a 250-meter buffer because that's what was considered as the area of that bike station, because it's not a large facility, so we don't expect the impact to go to 2 miles or 3 miles and so on. The second measure that we used for the effectiveness analysis is the accessibility to employment. So again, we wanted to see how job accessibility changed in response to these projects. So we used data from the American Community Survey from 2011 to 2016. We merged those with our census tract, Florida census tract shapefile, and we used this area as 10 minutes driving area. It's not a network. It's basically network distance. So we identified what is the area you can reach in all directions in 10 minutes driving time. And we saw how accessibility or how number of jobs in that 10-minute driving region changed. So we focused on that as the case area. For control area, again, we used a similar idea that we have an internal region and an external region. So for that, we did 10 minutes for the case. And we said everything between 20 and 30 minutes driving area will serve as the control. So if jobs increased uniformly in the region, we need to account for that baseline increase in the region. So that's why we have the control and the case. Okay. Yeah, I'll explain that. So this is how the case and control area look for the SunRail and I-4 station. So if you look at for each of the buffers, we have a 10-minute driving distance, and then the control is the blue area. So the 20 to 30 minutes is the control area that we used, and we measured how number of jobs changed in these region. And here we are plotting the distribution of jobs.
Naveen,
yes, sorry.
Are you sharing your screen, or because all we're seeing is, which screen are you sharing? If you are.
I'm sharing my presentation.
Okay.
Are you unable to see it?
Yeah, now we can. Thank you.
Oh, I'm sorry. Okay. Okay. I think, yeah, okay. I thought I was sharing the screen. Okay. So what these are the figures for the case and control areas. So if you look at the SunRail stations, from each station, we identified how far we can reach in 10 minutes. So that's what we did here. So this colored area represents the 10-minute area that you can reach from each of the SunRail stations. And the different spectrum of colors there show the current employment for a particular year in those regions. And then the control was obtained as distance of 20 to 30 minutes. So it's beyond 20, but less than 30 minutes. So the green area is not the control. The blue area is the control area. So employment in these regions and their corresponding increase will serve as a benchmark for the region. Similarly, we did the same for I-4. So we have a 10-minute driving area from I-4. So this is the case area, and the control area is again in this blue area. So jobs and their corresponding increase by year are measured in this case area, and they are compared to what happens for jobs in the control area. Again, the approach is qualitative in the sense that it is possible that there could be another downtown in this blue area. So it could skew some numbers sometimes, but we tried to do the best we can in terms of in this region. We were okay, but that's something we need to be careful when we're developing these control areas. We might have to mark out and remove some areas if required. For Juice Orlando distance, the same driving area would have been very large for the system that we have. So what we did was we simply considered a 2-mile distance band. We said within 2 miles is the case area, and outside that would be the external control area. The third measure that we used is the commuting time change. So here you're looking at how the number of minutes changed, number of minutes of commute time changed. Again, this is available from American Community Survey. So we used 1 mile radius buffers. The approach is very similar to what we did for property values, just that we are using census tracts and using commuting time here. So we used the same approach for case area and control area for all of them. So the measures are different, but the process remains the same. For Juice Orlando, again, we used a similar approach of the 250 selected buffers from there, and we used that process to monitor how commute time has changed in those regions. The fourth measure that we did is the land use type change. So in this case, what we are doing here is we focused on buffer areas, same as what we did in the property value area, but here we are focusing on changes across land use type. So we identified, for example, vacant parcels, and within that buffer, we identified how many of those vacant parcels changed year by year. Same thing for SunRail, same thing for I-4, so that we wanted to understand the impact on land use of these projects. Again, the procedure is very similar to what we did for the other MOs. The last measure that we did was we focused on travel patterns for zero car. So we have several mode choice alternatives. So car, truck or van, carpool and public transportation, walk and other modes. What we did was we wanted to see if these mode shares changed for zero car households. So we conducted an analysis using the, again, ACS data. So the approach again is same as what we did in the past, because the control areas and case areas were selected for SunRail stations using the same approach. And then we observed how mode patterns change for zero car households. Again, this is a tricky measure for zero car households in this region, because the number of records from ACS for this group is slightly on the lower side. So we need to be careful in doing this. Sometimes ACS does not have enough data in some census tracts for zero car households, because potentially there are not many zero car households compiled as part of the survey that was conducted by ACS. So we urge a word of caution when using these results, but this approach can be used in general with other demographic groups also. Same approach for the I-4 and Juice that we used for other measures was used for this metric also. So once we identified all the measures, once we were able to figure out how to conduct this GIS analysis on all of these measures, what we did was we compiled the data, and we are starting to we developed the results for these measures by project. So I'll show only a subset of the results. We have the project report that presents all the results in detail. Here I am presenting the property value variation for SunRail from different years. So if you look at the case and control, you'll see that the property values increased for SunRail in the SunRail vicinity in general much more relative to other corresponding control periods. For example, if you look at phase 2, the property values for some of these have gone up to 150 to, especially in 2016 and 2017, by a lot, while the case areas or the control areas only increased slightly lower relative to what we see in this picture. So this provides a clear benchmark. At the bottom, we have the benchmark increases. This is the increases around SunRail stations, providing us a sense of, okay, what is happening by land use type. So we are not just focusing on one kind of property values for single family, we're focusing on family, multifamily, retail, industrial, and institutional. And depending on where we are and what type of land use type we're looking at, across different parts of the SunRail system, the price increases are different. So again, this is of value to both SunRail as a system and also local agencies looking at what is happening in terms of the prices and their property value appreciation. For I4, the results are again of a similar nature with differences in where the prices increase is different. So for example, Ivanhoe region has more price increase than the other 3 regions. This is what we observed, especially for multifamily. For single family, the increase appears to be in the range of over 6 years, about 45 to 50%, which is along expected lines. In Altamonte, the single family increase, there was a drop in 2012 and then it started going up. So we are seeing a net increase of about 24 to 25%. Again, this is averaged for all parcels of that type. So all single family houses are considered, and we are looking at price increases for a uniform area of per acre basis. So this is about this is showing about a 25% or 30% increase over the 6-year time period. Then we also looked at a similar variation in pricing for juice. Again, because the juice system is reasonably smaller in range, the numbers are, we need to be careful with in considering these numbers because these are computed over smaller data points, but we still see a large increase in price value for the multifamily residential. Again, with the overall development happening in downtown Orlando, this makes sense that these prices are appreciating for multifamily residential units. We conducted similar analysis, as I said, for all the 5 measures of effectiveness. I know we are running out of time and I don't want to go beyond our time. So again, before I present the other metrics, I wanted to see if any questions are there from the participants. So if you have any questions, please feel free to discuss.
This is Ken in District 7. I had a quick question. Not being a Florida property owner, I rent since I moved down here. What is the assessment schedule in Florida? Where I was from, they did it once every year and it was in small geographic areas. And I'm just wondering if a large increase could be because that area was recently assessed.
So we get new values every year for every parcel.
Okay, that's great then. Thank you.
Yeah, so we have data from the Florida Department of Revenue that varies every year. So we have we have that yearly data. So we are getting data for all the parcels every year. Any other questions or comments? Okay, so I'll quickly show you the results for the other measures. So the accessibility to jobs was the second factor that we looked at. Again, we monitored how the number of accessible jobs changed across different parts of the SunRail project. So we have downtown, phase 1 and phase 2, and we can see that either in the downtown region they remain stable. In the phase 1 outside downtown, there are increases from 2012 to 2013, and then they remain stable after that. So we see these fluctuations. Also, the fluctuations exist in the case and control. Also, in control, you'll notice that phase 2 control has larger number of jobs compared to phase 1 and phase downtown regions. Again, this is the nature of the control area that was selected for the analysis. Same thing with we are plotting the changes in accessible jobs. As you will see, in attraction area, the number of jobs have increased. again, there's a consistent increase in the number of jobs. It's higher for attraction and I think downtown regions. In control also, there is ups and downs. There is for attraction control, there is some increase, sometimes even higher than what we have in the case region. But again, this is to come up with a benchmark to see what is happening, and we'll be able to identify if there is a positive change or a negative change in relation to the control project. So that is helpful in having a benchmark to compare and contrast. Again, for juice also, we were able to get the accessibility numbers across the years, and with the changes happening, we can see that they have increased in a gradual manner. In terms of commute time, so for commute time, obviously downtown stations have lower commute time compared to other categories. Phase 2 stations, as you would expect, will have longer commute times because the people residing in those regions are probably driving much further away. For I-4 expansion, we found that census tracts that are in case locations are likely to have lower commute times because these are locations which are nearer to I-4, so they have better accessibility and better transportation access to get to their locations. In terms of Orlando bike share system, we found that commute times were longer in the earlier years of the study period, but over the years the differences have narrowed down. Again, it might be tricky to gather all of that from this figure, so that's why we provided a quick summary. In terms of land use variation, we found substantial changes in terms of converting from vacant to single family residential and office. That's what we observed, especially for SunRail. Again, this is expected because a lot of housing has been built around these stations, and also office and retail area has come into existence. In terms of I-4 expansion, again, the same single family and office area are the major ones, and the results between the case and control are very similar for I-4. In terms of juice bike share, we see that, again, given it's mainly around in downtown region, we see a very small change in land use types across these facilities because there won't be a lot of vacant things. In terms of travel patterns, we found that public transport increased around SunRail stations for zero-car households, again, which is encouraging because given it's a public transport project. In terms of I-4 expansion, we saw that the share of public transportation is slightly lower in these regions around I-4, and it makes sense because, again, we have a very auto-oriented neighborhoods in those regions. So except for downtown where there was some growth in non-auto modes, we find usually it to be an auto-oriented pattern. Again, for juice, we saw increases in non-private vehicle modes substantially by about 10 to 20% in downtown and other stations. Walk also has increased. Walk mode also has increased about 5% in the downtown, but outside downtown stations, we found that walk activity has reduced. Again, we will urge caution in looking at these results because we had very few households of this category for our analysis from the census data. So, but this again provides a framework to do this comparison and validation analysis. So again, to give a quick summary, we looked at 3 projects, SunRail, I-4, and JUICE. We developed 5 measures of effectiveness, and we showed how to do the data analysis and also generated inputs over multiple years. In the seminar 3 of this series, we will be presenting, we have these measures of effectiveness. How do we use these to make the multi-criterion decision process? So that's what we'll be doing there. And in seminar 2, we will look at how social media data can be used, can be compiled and then analyzed to understand how people respond to the different transportation infrastructure projects from a happiness perspective or a sentiment perspective of their responses. So again, I'd like to thank also my former teammates, team members who have worked on this, Dr. Sabrina Noor, Dr. Baumik, and Dr. Bibash. All of these three, one of them was a postdoc on this project, and the other two were students, and now they have graduated. Now they're in their employment. So again, I'll be happy to take any questions, and we will be providing a link to this video, and also we will be providing some supplemental material that can be accessed related to the presentations and other slides and videos. Okay, yeah. Again, if there are any questions, I'll be happy to take them now. Okay, if there are no questions, again, thank you for attending the seminar, the webinar, and I'll be in touch with the materials for the video and other links in a few days. Thank you very much, everybody, and I hope you have a good day. Thanks.
Thanks, Naveen.